Okay, so since there's so many moving parts, let's do a few more examples just to make sure we're kind of seeing the patterns, and then it just takes a lot of work. So we're adding two fractions here. My denominators aren't the same. So we need to factor. All right, that's a classic difference of squares pattern there. All right, and then we need to factor. And this one requires our AC trick or our guesser to checkers. And again, you guys know I'm a guesser and a checker. You ACers, again, it'll just take you a little bit more time, but I think when all's said and done, the right combination will be that one. Right? So first times first is first, last times last is last. Outer's a positive, outer's a negative 4x, inner's a positive 3x, giving us negative x. So there we go. Piecing together our LCD, right? We're going to start with mom over here, right? She wants to do a 2x plus 3 and a 2x minus 3. Dad wants to do that, but we already have it. What's missing is the x minus 2. So there's our LCD. So coming back over here, and let me rewrite these in factored form. What's missing from this guy is the x minus 2, right? So we multiply top and bottom by x minus 2. In factored form, what's missing from this one? It looks like the factor of 2x minus 3. So I'll multiply both top and bottom by 2x minus 3. And so now what we have is x times x minus 2 all over our LCD plus x times 2x minus 3 all over our LCD. And of course, now that I have the same denominator, we can keep that denominator and add up what's in my numerators, right? So x minus 2 plus x, 2x minus 3. And so when we do that addition upstairs, we get x squared minus 2x. And it looks like a positive 2x squared minus 3x all over our LCD. Let me make sure I got that right. Yeah, so x squared minus 2x, yeah. And then combining like terms, it looks like we have 3x squared and a minus 5x, right, all over our LCD at the moment. All right, so again, there's the addition, all the little steps, finding our LCD, building equivalent fractions, right, keeping the LCD and adding up what's up in my numerator by combining like terms and distributing. What's left is am I in lowest terms? Well, the top, I can factor an x out of there, and I believe what's left is 3x minus 5. And on the bottom, we have 2x plus 3, 2x minus 3, all over x minus 2. So I don't see any common factors. So there is our final answer in factored form. So we're all done. All right, so the next one, again, we've got to build the LCD. So we'll begin by factoring. The first one is a classic difference of squares example. Right? The next one, I think the only way to factor that is to pull out an x. All right? So there's basically our factorization. Here's mom. Right? She wants to contribute an x minus 2 and an x plus 2. Dad wants an x, which is missing. X plus 2 we already got. So there's your LCD right there. So we're going to come back over here. Let me write this in factored form. What's missing from this one is x, right? So it needs a factor of x. And the next one, it looks like it's missing the factor of x minus 2. So I'll multiply both top and bottom by x minus 2. Okay? And then, of course, now I have 3x all over my LCD minus 12 times x minus 2 all over my LCD. So I'll keep that LCD and I'll perform my subtraction. Okay, of course, to perform that subtraction, we'll distribute. Let me make sure I did that distribution right. So we got 3x, that's a negative 12x, negative 12, yeah, plus, and then combine like terms, we get a negative 9x, right, plus 24 all over our LCD at the moment. All right, so there's the subtraction. Now what I need to do is make sure that it's in lowest terms. When I look at this, I think we can pull out a negative 3. And what's left is a 3x plus 8. And then, of course, our LCD is 2x plus 3, 2x minus 3, and an x minus 2. Again, I don't see any common factors. So that tells us that we're finished. There's our final answer in its factored form. So again, factor to find the LCD, play your equivalent fraction trick, right? Keep that LCD and perform your subtraction upstairs, combine like terms, do your distribution, and then factor to make sure your simplified form. So there you go. All right, the next combination, let's do a couple more here. Bring in another item into play. All right, so when I look at this first one here, we can see initially it doesn't look like I have the same denominator. But we know, right, we've seen that x minus 2 and 2 minus x, they're basically opposites of each other. So what I can do here, how about I take this side and I factor out a negative 1, right? And so that gives us x minus 2 all over 2x. That negative 1, right, I can, in a fraction, it doesn't matter where it comes, so I can kind of, oops, that's a minus sign, put that negative upstairs. Okay, so again, the negative 1 came from the factoring down below, right, but the negative can go upstairs or downstairs. And when I put it, or you just think of it this way, what's 2 divided by negative 1? It's negative 2. That might be an easier way to think about it. But what I now have is I have a common denominator. So I'll keep that denominator and I will subtract my numerators. All right, so how do I perform that subtraction? Well, in this case, minus a negative 2x is a plus 2x. And combining like terms, 2x and 2x is 4x plus 3 all over x minus 2. And we're done, right? Because the top doesn't factor, the bottom doesn't factor, and we don't have any common factors. So again, I'm using the idea that these are opposites, creating the opposite, right? Moving that negative around, and then I now have a common denominator which I can perform the subtraction. So the next one's kind of similar. Again, x minus 5 and 5 minus x are not the same, but we can pull out a negative 1, okay, and then this becomes, again, 25 divided by negative 1 is a negative 25. All right, and so now my denominators are the same, so I keep it and I add up my numerators. Of course, if I add negative 25, that's the same thing as subtracting 25. All right, and so there's the addition. All right, so I used my opposite trick, got my common denominator, kept it, and added. Am I simplified? Well, if we factor the top is a difference of squares example, right? The x minus 5s are now common, and our final answer there is x plus 5. So these two fractions add up to x plus 5 for all the right reasons. So there's, again, we hadn't seen that in a while, but that idea of using the concept of opposite, in this case, to create a common denominator that I needed. So there you go. So I think that pretty much covers everything in 6.4. As you can see, it's going to take a lot of practice. So make sure you're showing your work. Post some ideas on Canvas to make sure you're clear. Post your questions. Request some Google Meet time with me if you need a more talking through it, if you would. All right, see you guys around on Canvas or in Google Meet.